Hi, in this video, I will be showing you problem number 11, 8, 15 from the practice final. Find the radius of convergence and the interval of convergence of the series sigma n varying from 0 through infinity x minus 2 to the power n over n square plus 1. Anytime the question is radius of convergence or the interval of convergence, first we have to use the ratio test. The ratio test tells us limit is n approaching infinity, absolute an plus 1 over an is L, and if L is less than 1, then the series is absolutely convergent and hence convergent. And if it is more than 1, it is divergent, and it's equal to 1, the test fails, then you have to apply a different test. So we'll first start off with the ratio test and find an plus 1 over an. Here n must be replaced by n plus 1. So x minus 2 to the power n plus 1 over n plus 1 the whole square plus 1 divided by an. The an is only this part. Because it is divided by an, we will flip and multiply. So it is n square plus 1 divided by x minus 2 to the power n. We'll simplify this expression. X minus 2 to the power n, x minus 2 to the power n plus 1. So this gives us x minus 2 on top. Then we will write the expression as x minus 2 times n square plus 1 over n plus 1 the whole square plus 1. So at this point, we will simplify the second expression that we have on n. We'll divide the numerator and the denominator by n square. We'll divide the numerator and the denominator by n square. So this would be x minus 2 times n square over n square, which is 1 over n square. Here n plus 1 the whole square over n square plus 1 over n square. When we are dividing every term on the numerator by n square, every term on the denominator also by n square. So this would be x minus 2 times 1 plus 1 over n square, that goes on the top. Denominator, we will write this one as n plus 1 over n the whole square plus 1 over n square. So we get an plus 1 over an equal to x minus 2 times 1 plus 1 over n square divided by, within this parenthesis over here, we can reduce that to 1 plus 1 over n. So it is 1 plus 1 over n the whole square plus 1 over n square. Now we'll take the absolute value and also allow n to approach infinity. We notice that 1 over n square as n approaching infinity becomes 0. Same way 1 over n as n approaching infinity will become 0. 1 over n square as n approaching infinity would become 0. So we get absolute x minus 2 times all the rest of it would become 0 except 1. So it will be 1 plus 1 over n square, absolute of that, divided by 1 plus 1 over n the whole square plus 1 over n square. All these terms on n would become 0. So you are left with absolute x minus 2 times this becomes 0, this becomes 0, this becomes 0. So it is just absolute x minus 2 times 1. And according to the ratio test, that L has to be less than 1. So it has to be less than 1 for the series to be convergent. So we get absolute x minus 2 less than 1 for series to be convergent, which implies that radius of convergence equal to 1, which completes the first part of the problem. We have to do the interval of convergence, which is the second part of the problem. Right now we know absolute x minus 2 lies between negative 1 and positive 1. So x lies between 3, and if you move the 2 to the other side, it becomes 1. So x lies between 1 and 3. So now the question is, what happens at the endpoints? So we'll take the endpoints here, which are 1 and 3. We'll take 1 and we'll take 3 and then plug in into the original expression, which is sigma x minus 2 to the power n over n square plus 1. So let's start off with x equal to 1. Let's plug in x equal to 1 into sigma an, so sigma n varying from 0 through infinity. The original one, you are going to plug in x equal to 1 here, 1 minus 2 to the power n over n squared plus 1, which will become sigma n varying from 0 through infinity, negative 1 to the power n over n squared plus 1, which is an alternating series. So by alternating series test, we can conclude that sigma negative 1 to the power n over n squared plus 1 convergent. In other words, at x equal to 1, the series is convergent. So is it convergent or divergent? At the other endpoint is what we have to check. So let's plug in x equal to 3, which is sigma n varying from 0 through infinity, 3 minus 2 to the power n over n squared plus 1, which is sigma n varying from 0 through infinity, 1 over n squared plus 1. So we can compare this to the series, which is sigma 1 over n square. So compare to the p series, the sigma 1 over n square, and then we can either take limit comparison test or regular comparison test to show that the series is convergent. As the p series is convergent when p is more than 1, sigma 1 over n square plus 1 also converges. So we notice that x equal to 3 also the series is convergent. Therefore, the interval of convergence would be would be 1 through 3, both 1 and 3 are inclusive. So interval of convergence is 1 through 3, both 1 and 3 included. So this concludes the second part of the problem of finding interval of convergence. Hope this video helps.